Hello, Daniel. Hello, Jan. It's so good to see both of you. I think we finally were able to find the time in our calendars to talk about all things under the sun today. I can't share my excitement through the barrier of this tool, but I'm really excited to see both of you. Hopefully, we can connect in person over time. So, welcome to the podcast. I want to have both of you introduce yourself to the audience, especially, what's your life story? How did you get into the field of deep learning and your research area briefly, so we can go one at a time. Maybe Daniel, you want to start first, and then we can go to Jan.
Yeah, sure. So first, thanks for inviting us to your podcast. So my backstory is essentially that I was always interested in computers. I started coding already when I was 8 years old. It was in BASIC at that time. And at the university, I first studied chemistry because I was quite interested in natural sciences. But later I switched to computer science because that was a better fit for me, essentially. And that was even before the deep learning hype started. Yeah, I got into deep learning during my master's, where I had a side project, essentially, where I worked on vertebra detection in computer tomography scans. And deep learning was already on there, so convolutional neural networks were available then, and I started to use them, and I was quite surprised on how well they worked on these problems. Essentially, that's when I decided to get into deep learning and also do my PhD in this area. So yeah, I'm currently working on my PhD in the group of Michael Wandt at the University of Mainz. And there I also work with neural networks, and mostly for chemistry and physics, for molecule properties and equivariant neural networks, which are relevant in that respect. And yeah, then 2024 started with the ARC challenge, and that essentially got me into LLMs too.
Yeah, my name is Jan. I'm also studying in Mainz. I actually started with mathematics and not computer science, and then switched to computer science early in my bachelor. And I think my first deep learning project was my bachelor thesis, where I tried to do an optical character recognition on cuneiform scans. Like, it's the oldest known language, I think, and they have lots of tablets, and I tried to write a deep learning system that could categorize the different letters. And that was really fun, and I never stopped working on deep learning afterwards. And now I'm studying for my PhD in the same group as Daniel, so we are colleagues, and my field is more in the direction of basically cell-based or very discrete patterns, and how neural networks generalize on basically toy data. So cellular automata or very, very simple binary functions.
Amazing. Thank you so much, Daniel and Jan, to introduce yourself. As I was sharing before the recording started, I found you both, one through the ARC challenge, following that, and also on the Machine Learning Street Talk channel. That was a great talk and also a great interview. I am curious, what was your motivation to participate in the ARC Challenge 2024 at that time?
Maybe I can start. I found the ARC challenge, I think, 1 year before the actual contest started, and just thought it was a very interesting problem. Like, many of the benchmarks at that time were already starting to saturate. I think it was in the time of ImageNet problems or something. And essentially, you download a big model, you try to fine tune a few steps, and then you get 91 instead of 90.5% accuracy or something like that. And the ARC challenge immediately seemed like a hard problem in a way. Like, if I see a problem, I always activate my computer science brain circuits, and I think, okay, how would I design an algorithm to solve this before I even start thinking about machine learning models? And the problem with ARC is, for each single problem, it's pretty simple to design an algorithm. I would take this pattern and replace it with that pattern and move it a little bit, but it doesn't generalize. So I saw this and I thought, okay, this is impossible. I haven't even the slightest idea on how to start to solve these problems in a general manner. And yeah, that stayed with me. And when the contest started, I was playing around a little bit, trying some stuff, and talked to Daniel about it. And then I went on a holiday and then came back, and he was like, I got it. We can do this.
Yeah. So I actually learned from it when the challenge was already running. Jan just told me about it here. This is a cool challenge. Take a look at it. And he had already done some preliminary work with LLMs, I think. So, and it was getting a few percent, maybe 10 or 15% on the problems. And yeah, I found the challenge quite interesting, and I thought I should try it out too. And so when Jan was on holiday, I made some experiments and I got it to, I don't know what, maybe 30% or something on the public evaluation set. Yeah, so we found out that LLMs work quite well on this problem. And somewhere at that point, we decided, yeah, we should enter the challenge and try to solve the problems on Kaggle. But when we first submitted our first code to Kaggle, this was really frustrating because we had maybe 30% before on the public evaluation set, but on Kaggle, we only got to first to 3%, maybe then to 10% or something. We then realized that the tasks on Kaggle were different than the public set. They were much more difficult to solve. Yeah. But I think we stayed on it then and improved our program a little. And yeah.
I think we saw that we had a chance to perform quite well. I was always a little bit more pessimistic than Daniel, but he kept pushing and saying, yeah, we can do top 5, we can do top 3, we can do top 2. And I was like, yeah, maybe if we are lucky. But yeah, it worked quite well.
Amazing. I think I did a reread of your paper that you had published, and I think went back to the original genesis of the ARC challenge from Franzen. If you have to express this to a general audience, explaining them what the ARC challenge was and is, how would you describe it in your words?
I think in the most abstract way, it's a challenge that represents a lot of different cognitive puzzles, like it's like an IQ test or like something in that way. And the difficult part is that each of these conceptual problems is different from each other. Like that there are some problems that repeat, but they're mostly unique. So in the machine learning space, the models work very well because of the rich amount of data we have, which is not present here. So you have to, in a way, understand the priors that humans use to solve these cognitive problems. And it's very well designed for that. It's a good challenge. It's easy to understand. It's easy to view as a human, but it's very, very hard for machines to fit these cognitive patterns, basically.
I'm curious, maybe what you see as the long-term implication of researchers tackling this challenge. I know we have 2025 challenge right now. How do you see that developing, especially in the idea of developing this generalized intelligence?
Yeah, it's quite interesting. The new challenge is much more difficult. And I think the basic idea of the ARC challenge was to essentially stimulate the development of new approaches to solving those tasks. And the interesting thing is that is not quite what happened in ARC 2024, because everyone chose to use LLMs and no one really used totally different models, what was actually the intention of the challenge, because LLMs were essentially so good because they were pre-trained on so much data that they totally dominated this challenge with a little fine-tuning. Yeah, and that was probably not really the intent. But I think with the new challenge, there are maybe some new approaches needed. So it will be quite interesting what solutions will perform well here. I'm thinking of reasoning approaches, chain of thought, and maybe other techniques that are new. So it will be quite interesting what will be good on Act 2.
Yeah, I think one of the reasons why exactly that didn't work so well on Arc 1 with the new approaches is also the re-Arc data set when I think about it. Like Michael Hodel produced this amazing big data set of Arc tasks. And that's the only reason why we could even train an LLM on the tasks. But we don't have that for Arc 2, where the problems are harder and not the same. They go outside of the distribution a little bit. They are more complex. So we probably need a new approach here. And that's also, I think, one of the really, really interesting things about Arc, because if you look at the LLMs that appear like every week is a new LLM, and every time it's like a little bit better on a benchmark. It's 95% on this, 90% on that. But it's the benchmarks lose their signal a little bit, right? And the ARC contest is much more a clear signal for conceptual thinking, basically, or for out of distribution thinking. So it's very interesting to work on that. Yeah.
Yeah. I think one aspect for me which kind of stood out when I was reading your paper, but also just looking through all the work that has gone in, this breaking the idea that just using standard large language models, you may not be able to achieve that amount of accuracy that you got. And as you said, Daniel, that maybe this needs to change with the new ARC2 approach. Looking back right now to your approach in ARC 2024, do you already, I'm assuming you both are preparing for the ARC2, and also like, what have been in works at the moment in your approach towards ARC2? Is this something that you can share?
Haven't started working that much yet on the new ARC challenge. Like, we have obviously tested our old approach a little bit on the offline data. We have not submitted anything yet, mostly because we are really busy with our paper. We wrote a small paper for ICML for the ARC contest, which is now accepted. But yeah, there are a lot of interesting approaches, I think. There's one that is public, that's the ARC AGI without pre-training. They also submitted, I think, a paper award for the first contest. The very interesting part about it is that they basically don't need that much additional training data, right? They don't pre-train, I think, but just train each task separately. And I think approaches in that direction can work very well, because you have to keep in mind that you are so strongly data constrained on the second contest.
Just looking at the current state of large language models and these technologies, both of you have been in this domain, obviously with the ARC challenge, but also exploring it in your area of research. What do you see at the moment as the key limitations and also potentially technical boundaries of the current state of the art in language models? Especially every week there is something new, as you said. But from your perspective, what do you see as the current challenges and maybe limitations of these systems?
Yeah, thinking about it, I think what maybe these models lack is some state of internal registers or memory to store information that they process. The point is, if you ask an LLM a question like, who invented the telephone and when was this person born? So a two-step question, and you say answer in one step. The LLM cannot answer it, because the only memory the LLM has, it's its own generated output, essentially. So if it first writes a name, then it can maybe answer the question, but it doesn't work directly. And I think that is some shortcoming of the current LLM approaches. And yeah, that also happens in the reasoning models, where reasoning leads to a very long chain of tokens, which essentially is an internal memory stored in the generated output. And these long token sequences lead to other problems like long computation and inefficient attention over the long sequences. And I think maybe there's a better way of doing it by giving the LLM some kind of internal storage to process data. I'm not sure how you could do it, yeah. But I think that is one shortcoming. And also, of course, we have no persistent memory. Each time you start up an LLM, it's in the same state. And that's also a thing that is lacking quite now in the LLMs.
Yeah, I think the one-step solution solving thing is a little bit solved by reasoning, but not fully, right? We tested our ARC1 approach on Sudoku examples, for instance, where it tries to solve a Sudoku riddle, right? And that's very, very hard for LLMs, because they have to, like, you can design a Sudoku puzzle where the first space is missing, and in order to solve it correctly, the LLM has to immediately solve the first empty space, right? But you can design it in a way that this is actually the hardest part of the puzzle to solve. So it's almost impossible for the LLM to solve this in one step. And reasoning helps, but like Daniel says, it gets very expensive at some point. Like, if you ask a LLM to solve a Sudoku riddle using reasoning, it will almost never finish, because it repeats the Sudoku puzzle 20 times just to fill in one space or something like that. It's very, very expensive. And there are a few approaches, I think, that are very interesting, but I'm not sure if any of them solve the heart of the problem, basically. Like, Google published the Gemini diffusion model, and I tested it, and it also can solve Sudoku puzzles, even though there were some papers that claim that diffusion-based LLMs can solve these types of riddles very well. I think there are approaches that are coming soon that will be very strong, but I'm not sure what they are yet.
I think also energy efficiency as one of the spectrums on which these models are kind of evolving. There's a lot of obviously noise around smaller models taking less of the footprint. How do you see that as a potential limitation and opportunity with respect to the state of the art of large language models?
Yeah, that's one of the problems in Arc 2, right? Because we have the Kaggle competition and we have to submit it, and it has to run in 12 hours flat. And if you check the leaderboard or what the best Arc model is, it's O3 at the moment, OpenAI O3, but it takes like thousands of dollars for a single task of compute, which is completely crazy. So in a way, what we also saw in our solution is we had an easier time to evaluate if a solution is correct compared to finding the solution, which is a typical computer science problem, right? It's often easier to evaluate the solution compared to finding it. And I think the current approach is often scaling in inference direction or in reasoning directions, test time training or longer reasoning traces or something like that. But it basically just trades off compute for more correctness. And at some point, that is not usable anymore. The curves are mostly exponential or logarithmic performance for, linear gain and cost.
Amazing. One other thing I want to maybe approach it around the consumer class of applications around language models. I think right now I would say predominant 80 to 90, even maybe more percentage of general customers or general users are basically using the chat-based interaction with these models. And a lot of times I think there's point about the models do a really good job of mimicking understanding. And I think there are different, obviously, thought leaders in the space who have different opinions around that. But if you go to like a normal layman and kind of approach it, and obviously from a Turing test perspective, yes, it breaks and completely passes the understanding test.
Yeah.
How do you see that simulation of understanding that maybe for a broad range of end customers, end users of the system does a really good job of it? And I think you are taking a scientific approach defining what understanding really means. But from a consumer class who are basically using it on a day-to-day basis, it might see almost ready for a lot of their understanding challenges. How do you kind of tackle that and approach this dichotomy in understanding?
I think it's a complicated question, I think. And I'm not sure how broadly it holds. Like, I see a lot of people still underestimating LLMs and chat models, and a lot of people obviously overestimating them by far. But even I realize at the moment that if I'm having a question that is outside of my expertise, like about, I don't know, something in biology or something in social science, I ask O3 and it does its internet search and stuff. The longer time, I keep reducing the amount I double check it, basically. I start trusting it more and more, and I'm not sure if that's a good sign or a bad sign. But at some point, your skill level at fact-checking the LLM will not suffice to find problems. But at that point, you wouldn't have found another answer either way. Like if you are an average consumer, or if you're outside of your expertise, like if I ask ChatGPT a question about chemistry or something, I'll have to trust it. I will not find a more accurate solution by Googling. So I don't know if it actually changes anything for most consumers, if you understand.
Yeah. I think the reason this is interesting is because as a, let's say, broad range of customers, if it solves a general range of problems, I think the example that you said, I'm spending time finding a chemistry answer and compared to reading books and finding Google search, the most convenient, maybe the less cognitive load and the lazy approach is obviously just accept what we have. Even if it's 80 to 90%, that may be good enough for me to pursue. And I think for a lot of these users, when I talk to them as a technologist, I said, hey, why do you even spend more time on this? It does a really good job. I'm happy with what it is. I think obviously there's a risk that it gets out of the hand and people just start assuming everything gets out of it true. And I always think about this in the back of my mind is how much progress that we are making compared to the value it generates to the end customers. And I'm coming from an approach of a consumer class in production application oriented view of it. And I think that's where I think this dichotomy is very interesting is like, obviously when you're doing a mathematical operations, you want to focus on certain accuracy versus more subjective, where maybe a partial accuracy is still good enough compared to the performance of that particular model.
Yeah, I think a comparison, is the autonomous driving industry at the moment. I think it's Waymo produced a study where they showed that they, per 100,000 kilometers, have far, far less accidents than human drivers. But people are still very angry, basically, anytime the machine does a mistake, even though it's less probable than the human is. We have a different bar, basically, for the success of a machine compared to a human, because we are used to strict 99.999% correctness in machines, If it's not working every time, then it's a stupid machine, even though it can do as good as you or even better than you in most cases. But I also think if you then compare it like to what a human does, if you have a assistant that is sometimes doing mistakes or something like that, we have for other humans processes we have built to error correct basically, or to double check stuff. It's just much more frustrating when a machine does it, because you can teach ChatGPT to do it better, You can't say, no, you did it wrong, do it like this next time. And like Daniel said previously, then you boot up ChatGPT again and it's the same model, It can't learn from its mistakes.
Yeah, I think this is also something we do when we use LLMs to solve complex tasks like programming an app or a website. We actually call the model multiple times as if it were a team of people or models to solve that. It's very comparable to a human team in some way. I think this approach is what I find quite interesting in this respect, that you use the LLMs in such a way.
We will all become managers instead of engineers soon. Yeah.
I phrase it like we'll become almost like curators and gardeners of this system, rather than just building it from the beginning. I'm curious your take on benchmarks. I think obviously you hear a different view. I think the new version of Llama, when it was launched, a lot of people obviously talked about how it was optimized and was almost trained to pass and kind of beat the benchmark. I mean, with the ARC AGI also forming as kind of a new benchmark for generalized intelligence. What is your take on the role of these benchmarks, and also what would your definition be a better benchmark over time, similar to ARC AGI?
We have benchmark problems at the moment, right? I think they are saturating very quickly. And I think I talked with Daniel about it yesterday, that the problem with a benchmark is if you can build a benchmark for some broad problem like software engineering or easy math or grade school or even PhD level math, the existence of the benchmark often implies the existence of a rich data set somewhere else, or a broad number of tokens you can use in LLM training. If you are able to curate a data set, then LLMs can learn to fit this data set because the data exists, basically, which makes it very, very hard to create data sets that are hard for LLMs, which is one of the reasons why the data sets all get saturated very, very quickly at the benchmarks. But people are still very unsatisfied sometimes with the capabilities of the models. In a way, it's some sort of overfitting on benchmarkable problems, let's say. ARC avoids that problem by being a rather expensive benchmark to create, I think. It's a very labor intensive to create this benchmark. And there are not a lot of data sets for it that you can use. Like, you can't build a 1 trillion token foundation model because there are no 1 trillion tokens of ARC problems, basically.
Another point with the benchmarks is that for each model, in combination with the benchmark, you have a very special way the data is presented to a model. You have special pre-prompts for processing this benchmark. So the results of the benchmark might not represent what a normal human gets when he just asks the model in some random way. So yeah, there's also a difference. And that's also a general problem with the LLMs. I think that they are very capable, but the problem needs to present it to them in a special way. They are dependent on that to find a good solution. So the input formatting is often a problem, I think, with LLMs.
Yeah, I think there are some math problems I saw that LLMs can solve because it's a graphic that they have to interpret. But the problem, it's actually very simple, but the LLM couldn't read the picture. Nowadays they can, but
yeah, it's getting better.
Yeah.
Yeah, I think from my side, I think when I look at benchmarks, I asked this question kind of taking a step back. What is, I mean, we know human form of intelligence as one predominant form of intelligence. What do we call as benchmarks today? There are obviously IQ tests, and we basically getting away from that not being the only way of measuring the intelligence. And I think about different forms of intelligence, right? Spatial intelligence, kinetic intelligence. I almost see a family of benchmarks potentially, which becomes like almost a testing ground to not say that one passes across all benchmark is intelligent, but also there might be overfitting in one benchmark, but maybe underfitting in another benchmark. And I think they would still exist as another form of intelligence or kind of a different tree of intelligence in that species. And I keep thinking about that in terms of the progression of these benchmarks over time, keeping the human intelligence as a baseline.
I think it's very interesting to look from that perspective. The problem is that the big models are hard to evaluate in that direction. But for example, what I would find really fascinating if there was like a set of benchmarks like spatial intelligence and reading intelligence or something like that. Like you have, let's say, 10 different data sets, 10 benchmarks that fit with them. And then you train a model on 8 of these types of intelligences and then ask if it can generalize to a different type of intelligence. If we get something like that, that would be amazing. But obviously the big labs have no interest in trying that even because they want to have the best model. So they will always use all data they have. They wouldn't do ablation studies like that, I think, or at least not publish the models afterwards.
Yeah, maybe this is a little bit what is done with ARC. So if we take a pre-trained LLM and try it on ARC with just a few examples, this goes a little bit in that direction, I think.
Yeah, it's a very different type of problem than the models see normally.
Let's take a different approach. I mean, kind of connected, but also disconnected. I think if I look at Francois Chollet's view of program synthesis as being the central to real intelligence, mimicking the biological intelligence, let's call it. What is your take on this, especially that being central to reach something like general intelligence? It's connected to our conversation about benchmarks, even ARC AGI. How do you see those approaches, including program synthesis and other upcoming breakthroughs, relevant towards AGI?
That's also a very hard question. I always think about if program synthesis would be the right approach for ARC, but every time I think about it, it feels wrong to me. Or at least in the strict sense, because when I think about program synthesis, I think about like Python code or something like that. And when I solve an ARC task, I can explain how to solve it. Like I can say, okay, look for every like blue object and then shift it like 3 pixels to the right. And in a way that is a program, right? That is a set of instructions, but it's a very fuzzy set of instructions, let's say, that is broadly applicable. Like if we do computer science programs or if we define a program, it's often extremely restricted. And even if I say shift all blue objects 3 pixels to the right, what is a blue object? Spend a lot of work defining even a simple concept for a program to be able to run this algorithm. So there is something in this direction. I think there's a way of doing program synthesis that works on ARC, but I don't think you can generate Python code to solve these things unless you have like a very, very strong underlying domain-specific language or something.
Yeah, but in a way, I think this fuzzy type of programs is maybe how intelligence in humans might work, because we also think in more fuzzy categories sometimes. And also there is a parallel to the reasoning models, which can essentially describe the solution of, if you try to solve ARC with a reasoning model, it tries to infer the rules also in natural language and then apply them. So I think there is some connection here to intelligence.
But I think it's like disconnected, you need to infer the rules, you need to find the rules to solve this problem, and then somehow you also need to be able to apply them. And that can get weirdly hard to do correctly. And I'm not sure how the human brain is able to do this so well, like even transmit an idea like that. Like I can probably, like if you take 2 humans and one human only sees the challenge of an ARC task, but not the training data, and the other human sees the whole task, then the human that sees the whole task can probably completely explain how to solve the task, to the other human. He doesn't even need to see anything else. So we understand how to prompt or how to explain algorithmically to another human how to solve such a problem in such a general and fuzzy way that it can even be transmitted. It's crazy. And I have no idea how to apply that to the task with LLMs or with machine learning. But I think that's a big step in the direction of general intelligence or better LLM or better AI.
Staying on this piece of, the upcoming breakthroughs in the approaches, you both have been partnering, obviously, with the ARC Challenge 2024 and with the upcoming challenge. And I'm assuming both of you obviously share a lot of the ideas that you agree with. What do you both disagree with? What are the ideas that you individually disagree on?
That's a very good question. I'm not sure we disagree on that much. We often have long discussions about approaches, and in the end, if one person doesn't think it's a good avenue, the other person just tests it, and if it works, it works, and if it doesn't work, it doesn't. So we are very test-driven development, basically. Yeah, I don't know. I don't think we disagree on that much, but we have different conceptual approaches, I think. Like maybe that's something we disagree with. I think it's very, very important to have visual explanations of what goes wrong, while Daniel is like, no, just think about it. It's obvious.
Yeah. In that respect, we also had a little bit different approach when solving the ARC challenge. Jan was also trying, let's visualize it. Let's see what the problem is here. And I was just, let's just program it and test it and see if it works. And if not, we test something else. So we had a little bit different approaches, but I think that worked quite well together.
Yeah, and it's different approaches for debugging, basically.
Yeah, essentially that.
Amazing. I want to switch gears to something more in a different direction, especially if you look at the state of things in the world around these technologies. It could be seen as a lot of concentration. Could be in the US, in Silicon Valley, especially the companies that are originating from there. You both in Germany, almost I see as representing the state of AI research here. What is your take on the outlook of this work around general AI research and the work that you both of you are doing in Europe? I'm especially interested to see how you think that is going at the moment, also the place that Europe plays in the overall progress in this domain.
Yeah, like you say, most of the AI research is very US centric, right? And that's a little bit sad. Like we have Mistral in Europe, which does some cool stuff and pops up every now and then, but they are not state of the art, or they are not popular in the same way that Anthropic or OpenAI or Gemini are. But I know we have several cool startups, especially in Switzerland, where I think you come from, or are sitting at the moment. Like we talked, for example, with UFA Labs, which is at the moment at place 1 in the leaderboard, or Giotto AI, which is place 3 or place 2 at the leaderboard at the moment. And they are doing very cool experiments. And I think because the pressure compared to OpenAI or Google is so immense, they fan out to do more experimental approaches, basically. They try very wild stuff or very interesting ideas that a big lab like Google or Anthropic or OpenAI maybe doesn't try it. But I'm not sure. I don't know what they do behind closed doors, And I also, it's a little bit political now, but it might also be that because of the current administration, people start looking a little bit more towards Europe. I hope at least. It would be nice to have more things going on here.
Yeah, it's a little bit difficult in Europe, maybe. But yeah, the point is that we essentially don't have so much compute to train these big models here. And yeah, that's why that happens, that the startups try more different experimental things, I think, because it's impossible to just keep up with the big models that the big companies train. And also, of course, there's more regulatory problems, I think, in Europe when you want to train such a big model.
Yeah. Even in Germany, even the electrical cost is very high, so I wouldn't even try here. Maybe rent something somewhere else, but...
If you both had a magic wand, which you can use to maybe change the way the things are happening in Europe, or especially advance the space, what would you expect to change? What would you expect that, the magically things to change and appear over the next few years?
It's hard to say because there are so many second order effects for politics, right? But I feel, or I see it argued a lot at least, that the startup culture in Europe is a little bit too weak. I think the most of the interesting startups that I know are in Zurich, some in Berlin and some in London, I think. But they are pretty rare, and for example, the people I know that are studying with me, most wouldn't consider doing a startup. We don't have the same drive or the same culture that places like Silicon Valley or Zurich do. Um, and I think it would be good to have far more support for that. Like, there are, if you look at Y Combinator, for example, in Silicon Valley, they just throw around a lot of money for anyone that wants to do a startup and has a good idea. And we don't have, we have some similar things in Europe, but nothing that is as big and as easy to get into as Y Combinator. And so we are missing the culture, we are missing the support for such a culture, and I think also a little bit the political will to do something in that direction. So from my perspective, what I would like is just something like Y Combinator in Europe, because then I could get money from them. It would be nice.
Yeah, I totally agree on this. That was also my first thought, that we're somehow missing this startup culture like in Silicon Valley. Yeah, in Switzerland, there are some interesting startups, I think, but in Germany, there's not much startup culture in the AI areas.
And if you go to Y Combinator or something like that, then they often want you to move to the Silicon Valley for at least half a year or something like that.
Yeah.
So it's a very efficient way to pull people into the US,
Definitely. I think I see some emergence of the whole sovereign AI, especially in the landscape that we are living in, right? Trying to make sure that, for example, Europe has an AI Act, obviously pooling money to also form and support that growth. How much of that is on your radar as things to keep in mind, especially where territories and countries and continents start to build more sovereign AI setup within their perimeter? Do you think about it? Is this something for you to keep in mind also in the application of your research?
A little bit. I sometimes have like not really business ideas, but like funny app ideas or funny website ideas. They almost never lead to anything, but I like playing around with ideas in my head. I think I went through the AI Act once, and reading it, it sounded like my idea wasn't possible because they had something in there like LLMs are not allowed to emotionally influence people or something like that. But if you go through it, it's far less strict than I thought at the beginning. So, but the problem is even the existence of the AI Act is taking speed away from people. It's a small inconvenience, but if you stack enough small inconveniences, people will never try to do something. Also it's the same thing with the German data protection regulations. I don't want to start a rant, but I don't like them at all. That they have often good reasons for doing the stuff they do, but it's taking away speed from the system.
Sometimes overreaching then, and it was probably made to be targeted at bigger companies, but for small companies, these regulations are a big problem, I think.
Regulations are often easier for big companies because they are big and can hire people to solve it,
The work to solve it is essentially the same, no matter how big you are, yeah.
Do you foresee a model in which this can really change and work? Like, obviously, keeping the good parts of regulation, as you said, maybe apply it to larger companies of a certain size and impact in terms of revenue, because you want to see it in a manner where individual rights around data is protected, but also you don't want to slow down innovation and time to market, especially if it's an idea in the nascent stage. Is there a thing that you think about on what could a good model look like if it has to work in Germany or in Europe in general?
I mean, getting deep into politics.
That's a really difficult question. There are often exemptions for small companies, which is good, right?
But I think all governments know that this is a problem in some way. Like, I think basically every party in Germany had deregulation as part of their agenda. So everybody knows it's a problem, but it's a hard to solve problem because you want to reduce regulation, but a lot of regulation exists because of some good reason. Hopefully maybe we can solve this even with LLMs or something. Hopefully we can digitize a lot of stuff and then like regulation would be completely fine if it was easy to handle, if you can just ask the German regulation LLM, hey, I'm starting a company, what do I have to do? Please, God help me. And it just spits out like a 3 bullet point thing you have to handle, and then it's done, then it's fine. But it isn't like that, sadly. And you almost always have a fear of, okay, if I do anything wrong, is this going to ruin me later on, or is this really bad, or is it just like okay bad? Yeah, let's build that, Daniel. Let's build a data protection LLM that solves all regulation problems.
Yeah, I think it might be difficult to build an LLM that can solve all these things because there's a lot of juristical questions involved. Then again, if your LLM makes wrong advice, who's responsible?
Not us, it's the LLM's fault.
Want to start going through, obviously not making this a political podcast, but let's maybe switch gears to what we got excited about with the work that you both are doing. I know you are doing research, you're also participating in these challenges. Are there any ideas and breakthroughs that you're excited about, or potentially which are on horizon, that keeps you or keeps you up in the night and gets you excited every single day in your role as a researcher and working in this domain?
I have some. There's just too much stuff happening, so it's very hard to keep up. But I think the interesting ideas at the moment are all in the reasoning direction mostly. And maybe like the diffusion LLMs, like Gemini diffusion is very cool and very fast, but I'm not sure how good that will scale. But there are very interesting approaches to reasoning using reinforcement learning, even for things where you don't think they could apply. Like, I forgot the name, but there was one paper a few weeks ago that tries to generate engaging stories, like it's a story writing LLM. And they train it using reinforcement learning. I think it's VLM or something. I don't know what it's called. But they do so because the problem is when you have reinforcement learning, you need still a signal. Like is it a good text or a bad text that is produced? And you have obviously not a signal for this is an engaging story, except if you have a lot of people. So what they do instead is they do a reasoning after they take the first part of a story, then they do a reasoning step, and they want that the reasoning step maximizes the probability that the rest of the story would be generated. So basically, the LLM learns to get into the mind of the person who wrote the story. And it works apparently very well. And it's very interesting because it very elegantly circumnavigates the problem of not having a clear reward signal. And stuff like that could be very interesting. And otherwise, I'm just waiting for the next OpenAI model. It can't take longer than like 2 weeks or something.
I'm also quite interested in reasoning models right now and how to train them. And also if it is possible to train some reasoning process without having reasoning traces to start with. You usually have working reasoning traces that lead to the problem solution. You give them the LLM. But for example, in case of ARC, we don't have essentially reasoning traces that tell us how the problem is solved. Is there a way to make the model generate these from itself from the beginning, maybe to solve these tasks? So is it possible for a model to learn reasoning by itself without starting this with human generated data? Maybe is an interesting question that I'm thinking about. Yeah.
I was speaking to someone recently, again, outside the podcast context, and I think I wanted to get your take on it, and it is connected to the, ideas and potential breakthroughs, especially on reasoning systems. And this person is an evolutionary biologist. And I think he was talking about a lot of times, again, comparing to humans. If you ask someone, why did you do this? Or why did you arrive at answer? They will explain to you, but the process of explanation sometimes, or in most times, will not be as accurate or accurately describes their reasoning process. So this person essentially was talking about like looking at reasoning models and defining like chain of reasoning essentially forces the model to think of this in a structured manner. But if you mirror a biological intelligence, a lot of times there are biases, influences, emotions at play, which will be very hard to even put it into a reasoning context or even verbalize it. And from an evolutionary biologist perspective, he almost felt like you are dumbing down the reasoning process to make it as a structure, where actually in humans, it might be very organic, very messy. How do you both see individually this idea, and how do you see even especially rise of reasoning systems?
It's always so tempting to apply human thinking or human reasoning to the models, But I don't think that is correct in some cases, at least. I think there are some papers arguing that reasoning traces are not faithful to what the model is actually thinking about in the background. So you can have a reasoning trace, and the results that the model outputs at the end is something completely different. But it's hard to say. I think we are still missing some sort of interpretability, even though it feels very interpretable with the reasoning traces. But I don't think they are enough. They shouldn't be seen as a tool for understanding what the model does, but more like of calculation process. You shouldn't use it as explanation, but just as the model went in that direction. At least that's what I think. For example, there was the AI Math Olympiad, and I played a little bit around with the DeepSeek reasoning models for that. They were very silly sometimes. Like, you had a very complex math question, and in one of the cases, the model produced a completely correct reasoning trace for solving this math problem. But like in the last sentence, it was, but that solution seems wrong, so I will answer 5 instead. And then answered 5. And I don't know what happened there, but it was really weird. Yeah. So even though it feels like the reasoning constrains the models in a specific thought direction, I don't think that's always true.
Yeah, I think the reasoning process in humans is probably also partly unconscious, and not sure if it can really be explained in natural language completely. So if the models reason in human natural language, it might be do something different than humans actually do when thinking about things, I think.
And also you have the problem that because LLMs are only trained on textual data, that what they write or what they answer is nothing but a model of what a human would write. But it's also only a model of what a human would write and not what a human
Not what he
would
would
think.
think. That's what I meant, yeah. And that's also what a human might tell you if you asked him, what did you think? And because he has to express it in some language, yeah.
I was having an argument with someone about this, like how would explaining the reasoning would work in a world where there was no language. And I think that's kind of a very poetic way to think about it. Amazing. We're concluding almost at the final stage of our conversation today. I think you had beautifully described, the pace at which this is changing every few weeks. I think, Jan, you mentioned, let's wait for 2 more weeks, something brand new comes. I think as AI researchers, obviously you have to often keep your focus, but also be up to date on what's happening around you. And I'm assuming that's obviously a big challenge. However, for someone like an application focusing on technology implementation of it and may not be researching, it just feels like literally I'm going through an ADHD process, like attention disorder of all the time, moving from one paper to one model to the other. And there's just so much to keep up. And I'm curious, both of you, what is your approach first being sane in this world where there's so much of information, so much things happening? How do you balance out being at the top of things while having a clear focus within your areas? And that's part one of my question. I will kind of wait for your input before I go to part two.
Um, I have a pretty curated Twitter feed, I think, where I follow a lot of people that post interesting papers. That's every day. I think it's very annoying and weird that the best way to get my current research information is over Twitter, over x.com now. I don't like it, but I haven't found anything else yet. But I'm working on some stuff that hopefully helps me there. And at the same time, I skim a lot. So I look at a paper that I see and I ask, is that relevant for problems I am trying to solve? And then do it a little bit recursively. Like, what is the main idea? Do I understand it? Is it clear to me how I could apply this? And if yes, then I will only get back to the paper when I really try to apply this. So I try to only get the information I need at each point because it's just too much otherwise. With some exceptions, like if there's a very cool model that I think that beats everything else, I want to know how they did it. So I sometimes go into the code, sometimes check the GitHub and read the paper more carefully. But for 95% of the papers I see, I skim them very quickly and ask myself, is this important for me?
Yeah. I also find it quite hard to follow the news developments because so much is happening in such a short time. I mostly try to stay on top of the topics where I do my own research in, which I think is most important for me. And for general things, I just ask Jan because he's always very well informed.
If someone is like getting into this field, maybe as an application, thinking about applying it, and is already overwhelmed by this is the whole diversity of models, work, research happening, breakthroughs in some small and bigger ways happening all around the world. What would be your advice for them to be able to get into this field, as in to play around, understand what's going on, and secondly, to also contribute to this field? What would be your advice for them if they're starting from scratch?
Depends on the level they want to work at, basically. Like you say, on the application side, depending on how much of the LLM they need, it's very easy to understand what the model does or very hard, Like if you only do a wrapper around ChatGPT or another LLM, then you can treat the complete model as a black box and just assume that it's a miracle. You put text in, text comes out, perfect. It works. And in that case, it's very important, I think, to have it, to keep the model choice variable so that you can just switch around and test which works better. Does this prompt work better? Do I have faster inference here? It depends on your limits. If you go into it a little bit more deeply and want to do something that is closer to the LLM, like using the logic probabilities or something, you should have a broad understanding of what the LLM does. You don't have to go very deep into it. You don't have to understand the code that is used, but you should understand what it means that the model is autoregressive, that it produces probability distributions over the tokens and so on. And if you want to go in the research direction and really work with the models themselves, I think it's amazingly accessible to read some of the code that exists for the models. The Hugging Face code has for each model that exists in Hugging Face a modeling file where just the model is printed there, and they are not that complicated. There's more and more stuff stacked on top of them, but the central base of a LLM is very, very simple to understand and very hackable. So you can try to change some stuff, replace a layer or something, experiment with the token embeddings, stuff like that. It's, in my opinion, very accessible for people.
Yeah. That's also what surprised me before I got into ARC and LLMs, because before I knew the theory, but I didn't know the code or how they're implemented, and I thought this would be much more complicated than it actually is in the end. It's just these simple building blocks stacked multiple times, and it's pretty accessible. And it's also accessible from a compute-wise standpoint now. So you can run small models like a few billion parameters on a consumer GPU and experiment with them, fine-tune them. So I think there's quite a lot possible right now.
Yeah, I think people also underestimate how much you can do with fine-tuning, even with small data sets, and how much you can do with small changes on the architecture. Like, I didn't think it was possible, but Daniel in the ARC contest just basically replaced the full embedding layer with only like 50 channels. And it worked perfectly, and I was completely shocked that it works. The models are surprisingly robust towards small changes if you do them carefully and correctly.
And they're also robust in the training process compared to old models like ConvNets, where you had to get every parameter essentially right. The transformers mostly train to some acceptable result with standard parameters. It's not perfect, but it works quite better than the older architectures, I think.
Amazing. I think we want to wrap up. It's a pleasure to, have this conversation with you both. I think in an unlimited space of time and, opportunities, we could have gone in many places. Is there anything that you want to share? Maybe how people can reach out to you, how they can connect with you if they have questions on wherever you are more accessible.
Anybody that wants to talk to us can find us on LinkedIn. Very easy. Just send us a friend request and we will probably accept it. And I'm always happy to chat about research. And I think you can also find both our emails just by Googling us. I think we are not that anonymous.
I think they're in the ARC paper if you need
Yeah,
that.
true.
Yeah, just write us.
Amazing. Thank you, Jan, and thank you, Daniel. It was a pleasure. I really enjoyed
Thank
talking
you.
to you, and thank you for taking the time and energy in answering the questions, exchanging a good banter around this. Appreciate that.
We appreciate the invitation. It's nice to talk to you. Yeah.
Sure. Thanks for the interesting talk.
Likewise.